Welcome to physics class. How are you doing today? And I think we will take out today to ramp up all what we studied in motion. We have looked at motion, we looked at velocity or speed, velocity and acceleration. We were able to define all of that and their units. We also looked at the motion time graph interpretation. I showed you how you can derive a speed or velocity from a distance time graph. I also did show you how you can derive acceleration from a velocity time graph. And then we went further to deriving the three equations of motion. The three equations of motion, if you can still remember, where we said the first equation of motion is V is equals to U plus AT. Whereas the second equation of motion is that S, which represents distance, is equals to UT plus a half AT squared. And then the third equation of motion, which I also showed you, I said V squared is equals to U squared plus 2AX. And so we went further to explaining the different parameters, what they stand for. But today we are going to be looking at what is on the board: motion under gravity, that is free fall. Motion under gravity. When we consider motion under gravity, the first thing that should come to your mind is the gravitational pull on the Earth's surface for every object that is thrown up, just like what I'm doing now. Now, if we look at this marker which is on my hand, if I throw it up, it gets the particular point in the air and then start retarding. Okay? Now, we're looking at the motion under gravity. In other words, any object that is thrown up will certainly come down. Will certainly come down. And then we're also going to derive the equation of motion for a motion that is under gravity. Okay? Now, so if an object, particularly a stone, is thrown up, as it reaches a height, it starts descending. It simply means that it starts retarding, because the acceleration now will not be a linear acceleration, rather will be acceleration due to gravity. And for acceleration due to gravity, it's not going to be represented with A anymore, rather will represent it with G. So the first equation of motion under gravity is to have V. V is equals to U plus GT. Now, I'm going to use plus or minus. Plus or minus. Why I'm taking plus or minus is because if we throw the object, for instance, a stone up, what happens is that as it's moving up or upward, it is acting against the acceleration due to gravity, the gravitational pull on the Earth's surface. So it's opposing it. So in that case, we have V is equals to U minus GT. Now this when it's thrown up. And then when it's descending, it becomes V is equals to U plus GT. Don't worry, I'll write out all the three equations of motion under this topic. But I just want to explain it to you first so that you can understand it clearly before you pen it down. I said, I'll take it again. When a stone is thrown up, it retards. When it gets to a particular height, it retards. Or even before it reaches that height, the gravitational attraction of the Earth is already acting on it, trying to pull it downward. And before it pulls it downward, the acceleration already is negative. Why? Because it's acting opposite against the Earth gravitational pull. But when it gets to a particular height, it starts descending on its own, naturally on that influence of the gravitational pull of the Earth's surface. When that happens, the acceleration due to gravity will not be negative anymore, but rather will be positive because it's just descending with the acceleration due to gravity on the Earth's surface. But when it's going up, is in opposition with the what? The Earth gravitational pull. So G is negative. Is that clear? Okay. Now when we also look at acceleration or equation of motion under gravity, the thing that ought to be changed from these three equations is our S becomes H. In other words, the distance becomes the height, and then A, which is linear acceleration, equals G, which is the gravitational acceleration. So we can rewrite the whole of these three equations, or wherever we have seen S, we use H, and wherever we see A, we put G. Is that clear? Okay, so take this down briefly before we continue. Alright, now we said the equations of motion for a body moving under gravity are obtained by replacing X and A of the equation by H and G, where H is height of the object above the ground and G is the acceleration due to gravity. Thus, the equation of motion under gravity are given by, now the first is V equals U plus or minus GT. I said V equals U plus or minus GT. That's the first equation of motion under gravity. The second equation of motion under gravity, don't forget, why would we consider the equation of motion previously? We had to use S here. And I've told you that wherever you see S, you replace it with H, which is height. Okay? So H, which is height, which is also spelling out the distance covered, is equals to UT. This is UT plus or minus a half GT squared. That's the second equation of motion under gravity. The second equation of motion under gravity. Whereas the last equation of motion under gravity is V squared equals U squared. This is U squared plus or minus 2GH. So don't forget, G is acceleration due to gravity, H is height, V is final velocity, and U is initial velocity. Now let's take an example. I have an example on the board. A ball is released from a height above the ground. Find its velocity after 5 seconds. Take G as 10 meters per second squared. A ball is released from a height above the ground. Find its velocity after 5 seconds. Take G as 10 meters per second squared. Now we'll quickly try this out. If there's time, we'll take another exercise before I give you an assignment. Right? Now, if you have an exercise of this form or a problem, how do you solve it? I've told you before now that you have to first of all ascertain the particular equation of motion to apply by stating what you have been given. Now, in this question, we have been given, first of all, that its velocity after 5 seconds is what we have to find, but we have been given G, which is acceleration due to gravity, is 10 meters per second, right? We have been given time, T, which is 5 seconds. So I will write given that G, which is acceleration due to gravity, is equals to 10 meters per second squared. And then we are also given that time T, okay, so I said given that time T is 5 seconds from that exercise, and then acceleration due to gravity is, which is G, is given as 10 meters per second. So what equation are we supposed to apply? If we pick, we are looking for V, which is final velocity. Final velocity V is not given. So we'll put a question mark there. Whereas initial velocity, if you look at the question vividly, let's say a ball is released from a height above the ground. It means it's without initial velocity. So we can therefore invoke the first equation of motion, which is V equals U plus or minus GT. Is that clear? Now, looking at it, I explained earlier, I told you that when the object is moving upward, what happens? When the object is moving upward, its acceleration due to gravity is negative. But when it's moving downward, it's a free, in other words, the influence of the acceleration due to gravity is not opposing it. So that is when it is positive. So if you look at the question again, we said the ball is released from a height. In other words, it is released from a height. So it's coming downward. So it's going to be V equals U plus GT, not minus GT. Is that clear? Okay. So in this case, we said our initial velocity is 0 because we are asked to find the final velocity. So if I say 0 plus G is 10 meters per second squared times time, which is given, which is 5 seconds. At the end of the day, V is equals to 10 multiply 5. 10 multiply 5 is what? 50. That's 50 meters per second. Is that clear? Is that simple enough? Right? This is simple, but let's see the first or the second exercise now. This is the first one. Let's look at the second exercise. This is easy to calculate. Okay. Alright, now the second exercise is more tasking compared to the first. It is thrown vertically upwards with an initial velocity u meter per second. It reaches a maximum height and returns to the ground. Find an expression for the maximum height to the velocity on hitting the ground. You see it? Yes. What do we do? Solution. Now the first thing that we need to carry out here is at maximum height. What happens? At maximum height, final velocity is equals to 0. So you take them at maximum height, V equals 0. Look at it again. What did we say? We said, now we're looking at initial velocity is the velocity the object has, immediately the motion is set on or set up. And then we're looking at a stone is thrown vertically upward with an initial velocity, which is given, is on the board. It reaches a maximum height and returns. Now they have spelled it out for us as this particular stone reached a maximum height and then return to the ground. So we are to find what? Derive an equation. We are to find an expression for this maximum height, h. In other words, we are looking at h. How do we find h? How do we calculate h? It therefore means that if v, which is final velocity, is equal to, we are certain that it's going to be the entire equation of motion, which is v squared is equals to u squared plus or minus 2gh. Okay? V squared is equals to u squared plus or minus 2gh. Okay, now Of course, you know, I keep explaining if G is supposed to be positive or negative. Now you can see for yourself. Okay? V squared is equals to U squared minus 2GH. I don't need to explain that. Okay? For the fact that G is what? Is opposing the gravitational attraction on the Earth's surface. It is negative. That's the motion. It has to be negative. But if it was not, it was coming down freely, then it is positive. I hope you got that. Now, from here, we have shown that at maximum height, V is equals to 0. That is, the final velocity is equals to 0. So what do we do here? How do we derive an expression for the maximum height? It simply means making H the subject formula. So from here, we have this is equals to 0, is equals to U squared minus 2GH. From there, we can say that H is equals to U squared over 2G. Is that clear? So we have derived an expression for the maximum height. Now, if I go over it again, a stone is thrown vertically upward with an initial velocity u meter per second. It reaches a maximum height and returns to the ground. Find an expression I for the maximum height to the velocity on hitting the ground. Which is what we are going to look at shortly. But before that, I've said that maximum height V is equals to 0. And then the suitable equation is V squared is equals to U squared plus 2GH. And then since at maximum height V is equals to 0, it means that final velocity is equals to 0. And since final velocity is equals to 0, what do? We make H the same formula from this. And that's what we have on the board there. Now H is equals to U squared over 2G. Now for the number 2, let the velocity on hitting the ground. So let the velocity on hitting the ground be V. Okay? Let's write I'll say let the velocity on hitting the ground be V in meters per second. Right? If the velocity on hitting the ground is V meter per second, we have that V squared is equals to U squared plus or minus 2GH. Right? Still the third equation of motion under gravity is what we are applying. But in this case, U is equals to 0. If you look at it critically, U is equals to 0. Okay? So in other words, if I'm going to take plus, I have V squared is equals to U squared plus 2GH. That means the stone is coming down. Is that clear? So that's why it is positive there. And once that happens, we know our initial velocity is equals to 0. So we have V squared is equals to 0 plus 2GH. V squared is equals to 0 plus 2GH. Therefore means that V squared which we are asked to find, the velocity on hitting the ground, is equals to the square root of 2gh. Is that clear? Because if we square both sides, it takes away the square here. So v is equals to the square root of 2gh. Is that clear? So we have been able to answer the first and the second exercise. Now I want to give you finally an exercise before an example or an assignment. Okay, now you have on the board, calculate the height from which a body is released from rest if its velocity just before hitting the ground is 30 meters per second. Calculate the height from which a body is released from rest if its velocity just before hitting the ground is 30 meters per second. That simply means if we have to solve this, what equation of motion are we to apply? We have, that should be v squared is equals u squared plus 2gh. On the fact that we are looking for the height h. We're looking for the height h. Now, from this equation, it's obvious I told you this is 0 because at maximum height, v, final velocity is equals to 0. And then we've given that just before it hits the ground, that the velocity is what? 30 meters per second. Right? 30 meters per second. So if we are to make h the Soviet formula for which we have done previously, if you look at the expression we derived, we can simply apply that directly, such that we have that if this is 0, it means that u squared is equals to 2gh, and then h is equals to what? U squared over 2g. Right? And we'll be given in our question a u initial velocity is 30. Of course, you know acceleration due to gravity is always 10 meters per second squared. Acceleration to energy is given as 10 meters per second squared. So from there we can say 30 squared over 2 times 10. So for the 10 is the acceleration due to gravity, which is the same thing as 900 over 20. And at the end, if you divide this, we'll go with this, and 2 into 9, that'll give us, into 90, sorry, that will give you 45 meters. So at the end of the day, h, therefore, h is equals to 45 meters. So the height from which the body is released from rest is 45 meters. I think it's simple enough for those of you in SS1 to calculate. Okay, you can try this at home. Assignment. You can try this at home. I said a mango fruit drops to the ground from the top of its tree, which is 5 meters high. This is 5 meters high. How long does it take to reach the ground? A mango fruit drops to the ground from the top of its tree, which is 5 meters high. How long does it take to reach the ground? 2. A body which is uniformly retarded comes to rest in 10 seconds. This is 10 seconds. After traveling a distance of 20 meters. After traveling a distance of 20 meters, calculate its initial velocity. So you solve this and send your note to me. This is where we will end the class, and we have come to the end of motion. we have ended motion in this segment today. So in our next class, we'll either be looking at projectile or equilibrium of forces. Is that clear? So anything you don't understand as regards motion from when we started defining what acceleration, velocity, and speed were, and then we defined also the motion time graph and interpretation. Anything you don't understand, even up to this point, please communicate back to me through your note. Is that clear? And then also do this assignment. See, we'll meet again next week or in our next class. Do have a pleasant time. Bye.